Hello, this is Cameron McClure-Coleman. This is my presentation for the Physics 143 extra credit assignment. I am a computer science major, so I chose dynamic random access memory as my device to present on, and I'll be presenting about the concepts of electricity and magnetism that we've learned and how they connect and are used in dynamic random access memory. So this slide here kind of gives some background on what dynamic random access memory is, referred to as DRAM. In a computer, both information and instructions for running programs are stored in bits, either 0 or 1, and those are combined into strings of bits, usually 8, 16, 32, 64, powers of 2 long. Most personal computers use chips that contain multiple gigabytes of DRAM. 1 gigabyte is 8.5 billion roughly bits, so there's a lot of bits to control, which means there's a lot of circuitry to support that. Here's on the right a dual inline memory module, sometimes referred to as a RAM stick, which contains 8 1 gigabyte DRAM chips. You can see those black chips that say S power on them for this module, or the DRAM chips. And each of those DRAM chips contains a bunch of circuitry necessary to read and write to the individual bits contained in them, and the card that they are housed on has circuitry to interface those chips with the processor of the computer. So bits in a DRAM chip are stored in arrays, and the information in each bit is stored using a capacitor connected to a transistor. Each capacitor represents either 1 or 0 by being charged or uncharged, and you read and write from them by checking if they are charged or uncharged using a special circuit. So I'm going to give a closer look at what a memory cell looks like individually here. You can see the circuit diagram below for a charged and uncharged capacitor representing either a 1 or 0 bit. Each cell has one capacitor and one transistor, and when the word line has current flowing through it, the transistor is open, which allows current to flow across it. And if a bit line is charged while a word line is charged, then the current flows from the bit line across the open transistor and across the capacitor charging it, and then the word line is turned off and the transistor closes, which then causes the capacitor to stay charged after the bit line turns off. If a capacitor is being written to 0, then the word line is turned on and the bit line stays at 0 or no current, allowing the capacitor to discharge all of its charge into that circuit that was created through the bit line and the ground. All right, moving on. Okay, so I mentioned earlier that DRAM chips are organized into arrays, and this is because actually it's more efficient to read and write to multiple bits at the same time. Since you're storing your information in chunks, you might as well read and write it in chunks. Makes it faster. So on the bottom right here, you can see a 4x4 array. This is a lot smaller than what you would find in a modern DDR5 DRAM chip. Those actually have multiple thousands of columns and rows, and so you have to have extra circuitry to select which bit lines you actually want to read or write to, and then also the circuitry that same circuitry you'd have here to select the word line that is active. And you only have one active word line at a time, so that when your bit lines are turned on or off, they're not affecting capacitors on other word lines, and those capacitors on other word lines are not affecting the capacitor on your target word line. So I'm going to move on now and show how you can take advantage of this circuitry to read and write to cells. Okay, so starting with reading, bit lines are pre-charged to half the capacitor's on-state voltage. So for a DDR5 RAM stick, you would have 0.55 volts running through your bit line, and then you would turn your word line on, opening the transistors for the that opening the transistors to the bit line current. Um, so that means that 0.55 volts is either added to by the capacitor that is now connected to it, or subtracted from by a discharged capacitor charging off of that bit line. So you then have less voltage running through or more voltage running through your bit line. And at the bottom of your bit line in this diagram, you have a sense amplifier that detects that change or variation from 0.55 volts, either up or down, and pulls it all the way to 0 or all the way to 1.1 volts by adding or subtracting voltage itself. Then you have 0 or 1 volts in your bit line, which then writes back to the capacitor what it was, and also coming out of your bit line into the rest of the circuitry that'll transmit the signal to your processor. So you now have 1 volt and 0 volt in all the places that it needs to be. All right, moving on to writing. Okay, so for writing, bit lines are pre-charged just like they were for writing, or reading, I mean. And you then have 0.55 volts for EDR5 running through all the bit lines. And then the selected column sense amplifiers are sent a signal this time. Instead of being written, or instead of being read from, they are sent written to, and you use a stronger signal. In the case of DDR5, that would be 1.4 volts. So now your bit line, all the ones that are supposed to have one bit, a bit that is 1 in them, have 1.4 volts running across the bit line, which causes the capacitor to then be charged to 1.4 volts. The sense amplifiers that are pulled to 0 for the overwrite here are then going to pull that bit line to 0, allowing the capacitor to discharge if it was charged, or stay at 0 if it was not. You might be thinking that that's weird that you're writing 1.4 volts when 1.1 means 1, and that's okay because in RAM stick, the transistors and capacitors are so small that electrons are actually able to leak across the boundaries because they're only a couple atoms across at the boundaries. So they will slowly discharge back to 1.1. And now you might be worried that, well, you're going to lose your memory if you're not reading and writing to it. And yes, you will. So there is a refresh operation that runs multiple times a second. And similarly to the read operation, allows the sense amplifiers to just push or pull your capacitors back to 0 or 1. All right, so that is an explanation of how the circuitry and components work in a RAM stick on a computer. And thank you for your time.